This video will have a look at how do you determine the equation of a parabola by being able to look at the graph and compare it to the standard parabola of y equals x squared. So having a look at the standard parabola of y equals x squared, we can see that it has a minimum turning point at 0, 0. Now the y equals x squared parabola is our standard parabola that we can use, and then we can look at the movement from that standard basic parabola to be able to help us to determine the equations of other parabolas that are on the same graph. So let's have a look at what some of the movements will be and how that movement will impact on the equation. So the first movement we're going to have a look at is movement along the y-axis. So that is movement up and down the vertical axes. So we can see that in red we've got our y equals x squared basic parabola. And the first one we're going to have a look at is the movement to y equals x squared plus 4. So when we've got our plus 4 on the end, that means it's going to be moving up the y-axis 4 places. So my turning point goes from 0, 0 up to 0, 4. The second parabola that is on that same Cartesian plane is x squared minus 3. So when we've got a minus 3 on the end, that means our parabola is going to be moving down 3 places. So our turning point goes from 0, 0 to 0, negative 3. So movement along the y-axis, we're going to have a number plus or minus onto the end after the x squared, and that is going to move it either up or down the y-axis. So next we're going to have a look at moving along the x-axis, so moving sideways instead of up and down as we were looking at before. And again, we're starting off with our y equals x squared basic parabola, which is in red, which has our minimum turning point of 0, 0. And the first equation we're looking at is x plus 3 squared. So this time our plus or minus is within the bracket before we apply the square. So x plus 3 squared. And when it's within the bracket, it moves along the x-axis, but it does it in a way that's opposite to what you see in the bracket. So plus 3 moves it negative 3. So it moves it away from the x-axis down to the negative numbers. So plus 3, our turning point, then becomes negative 3 and 0. So x plus 3 squared moves it along the x-axis, but it does it in the opposite direction. So having a look at the second equation, x minus 5 squared, this time we have negative 5 inside of the bracket before we apply the square. So that means we're going to move it in positive 5 direction. So it moves from 0 up to positive 5. So the turning point goes from 0, 0 up to 5, 0. So when we've got a plus or minus inside of the bracket before we apply the square, that means we're moving it along the x-axis or moving it sideways. So summarizing those two movements, when we have a plus or minus on the end after the square power, then it moves it along the x-axis. When we've got a plus or minus inside of the brackets before we apply the power, then it removes it along the x-axis. So the third movement we'll have a look at is when the parabola reflects across the x-axis. So when it reflects across the x-axis, instead of having a minimum turning point, it then has a maximum turning point, and our equation is negative x squared. So if we've got a negative in front of the x, it reflects the parabola across the x-axis and turns it into a maximum turning point. So that is the third movement that you need to be aware of in determining parabola equations by comparing it to our standard parabola of y equals x squared. So let's have a look at a couple of examples of how we can determine these equations by making that comparison. So in our first example, starting at y equals x squared, our basic parabola that has that 0, 0 turning point, we can see that our parabola is actually moving up to 5, so the turning point becomes 0 and 5. So when we're moving up the y-axis, that means we've got a number on the end, and because we're moving positive 5, our number is going to be positive 5. So our equation will become y equals x squared, and then plus 5 onto the end. In our second example, Again, starting at a basic parabola of y equals x squared that has that minimum turning point at 0, 0. And we are moving across the x-axis and we're moving across till we get to positive 4. So when we're moving across the x-axis, we are then putting a number inside a set of brackets before we square our equation. So the equation for the graph shown in the example is going to be y equals, and then because we've moved to positive 4, when we do our equation, it's going to be the opposite, so it will be negative 4. So it's going to be x minus 4 in brackets, and then to the power of 2. So the equation for the example is y equals x minus 4 squared. So looking at our third and last example, again, we are starting with y equals x squared. So we're starting with that minimum turning point of 0, 0. And we're having a look and seeing where the line has moved. And this time there has been 2 movements. So we can see that along the y-axis, we are moving up to 4. And then along the x-axis, we are going to be moving across to 3. So when we come to write the equation of our new line, there's going to be 2 changes to that original y equals x squared. The first change is going to be across the y-axis. And when I move across the y-axis, we are adding a number inside with x inside the bracket before we apply the power of 2. And because it's positive 3 and we're moving along the x-axis, it's going to be the opposite. So it's going to be negative 3. So it's going to be y equals, and then x minus 3 squared. And then we need to add in our movement along the y-axis, so up 4, which would be positive 4. So the equation for the line in the example is going to be x minus 3 squared plus 4.